Hello students, so we are going to study periodic table and periodicity of the elements. So let's start. Periodic table. Now, one of the scientists who tried to make periodic tables, most close one was our Mendeleev. Okay, so then came Moseley. On the basis of his experiment, modern periodic table is formed. Now we have to know what is the experiment. So let us see the Moseley's experiment and what are the results. So Moseley experimented with X-ray and with different atoms, and he saw a particular pattern, and from that he concluded that root over of frequency of the X-ray emitted is directly proportional to atomic number of that element where the X-ray is passed. So from that he deducted two graphs. One is root over of frequency versus atomic mass, and the second one is root over of frequency versus atomic number. So these graphs came like this. The first one came like this, and the second one came like this. Okay. So from that, he concluded that physical and chemical properties of an element is the periodic function of its atomic number, because we saw in the graphs previously that the atomic numbers graph is kind of straight line. Okay, so let's write the conclusion, that is physical and chemical properties of an element is the periodic function of the atomic number. So in known 118 elements, okay, the periodic table is made where there is 18 columns, that is called groups, and 7 horizontal rows, that is called our periods. Okay, now we can remember this 118 elements and if question came from that, so we can really remember that, right? So we are gonna remember short periodic table. Okay, it will be sufficient for NEET. Any questions that comes from periodic table will come from that short periodic table. I'm gonna tell you. So, so to form a table, we will need 8 columns and our 6 rows. Okay. Now, what are these columns called? They are called groups. And what are these rows called? They are called periods. So let us specify the groups. It will be group 1, group 2, group 13, group 14, group 15, group 16, group 17, group 18. And it will be our first period, second period, third period, fourth period, fifth period, sixth period. So first is our H, then after that LI, NA, K, RB, CS. Then comes BE, MG, CA, SR, BA. Then comes boron, aluminium, gallium, indium, thallium. Then comes carbon, silicon, germanium, tin or SN, PB. Then our N, nitrogen, phosphorus, arsenic, SB, BI. Then O, S, that is oxygen, sulfur, selenium, SC, TE, PO, polonium. Then comes our fluorine, chlorine, bromine, iodine, AT. And the last group is made up of noble gases, that is helium, neon, argon, krypton, xenon, radon. Now we have to memorize this whole. We are not going to memorize 118 elements, but we are going to memorize this. Okay. So any question comes from this, like any property. Okay. They will ask you that arrange them on the decreasing order or increasing order. They will give you this Li, then B, then from here G, or oxygen or fluorine. You can just remember this or write this on the answer or rap sheet, and then you can conclude it from that. So you have to memorize this. Okay, it will be easier and less time consuming for you guys. So from the periodic table, we can conclude that first period is of 2 elements, second and third period is our 8 elements. Okay, fourth and fifth period is our 18 elements, and sixth period has 32 elements in modern periodic table. So they will ask you that which periodic table consists of most of the elements. So you can easily answer it will be the sixth period. Okay, so, or they can answer that which is second highest, so it will be fourth and fifth period. Okay, so they ask these questions. Also, we have to know that which group is called what. So let us see that there are four block elements. Okay, as we saw in atomic structure, that is SPDF. So group 1 and 2, that is called S block. 3 to 12, that is called D block. 13 to 18, that is called P block. And here is an exception, that is if they ask you which group consists of A block elements. So all A block elements consist of group number 3. Okay, all the A block elements. So we are going to study these block elements. So we are going to study now S block elements. So what is its common electronic configuration? That will be NS 1 to 2. So here we have to know a thing, that if they give you an element, so you don't know that it will be S block, A block, D block, or which block. So you don't know, right? So you have to write its electronic configuration. So from that, if you see that the last group or the last that block comes, that is S. So from that you can conclude that N will be the period in which that element is, and if it is under the S, that is the electron configuration will give you that it will be S block or A block or P block. So either it will be in the first group or will be in the second group. So that's why the common electronic configuration is written like that. Okay. So now let's see the what the groups are called. The first group is called alkali metal group. Okay. And second group is called alkaline earth metals. So this group has electronic configuration NS1, and this group will be NS2. So S block is done. Now we'll see the P blocks. P block elements. So in this P block, we can see three kinds of elements. In S block, we only see metals, but in P block, we can see metals, non-metals, and also metalloid. Okay. So what will be its common electronic configuration? That will be NS2, NP1 to 6. So if a P block comes at the end of your electronic configuration, then Many students confused that how can we decide which group and a period will be that element of. So for that we have a formula that group number will be S plus P plus 10. Okay. So what is that? That if you let us assume that one element is given like this. Okay. Let us assume it is NS2 NP3. So what will be the group here? So we'll write 2 plus 3 plus 10. That will be group 15 element. Okay. And we know that here n will be our period. So nothing to worry about. Now our P block is also done. Now we'll come to our D block elements. So D block elements, we're gonna read it in inorganic elaborately. So don't worry about it. Just know the electronic configuration for now. That is n minus 1 D 1 to 10 NS2. Now in this block, we can see one thing that they are d orbitals. That means we know that the orbital has 5 subshells like this. So one of their orbitals will be unfilled. Minimum one of their orbitals will be unfilled. If they are not unfilled, so then that will be called non-d block elements. That is our Zn. Okay, but they also included in d block. But the d block elements criteria, main criteria is that one of their minimum one of their subcells will be unfilled. Okay, so d block elements are also called transition elements. We're gonna read it in organic, though I am saying it. Okay, so transition elements. So Fe, Mn, Cu, Cr, Co, these kind of metals include in this group SCV. Okay, so we're gonna see it there. So then comes our A block element. Now its electronic configuration is kind of complicated. So give it a very importance. Okay. So what there are two series which include in the A block elements. That is our lanthanoid series and actinoid series. Now here is a funny exception, that is the groups named on the basis of these metals, but these two metals, okay, doesn't include in the A block. So it's kind of funny, right? Their names are made up of these series, but they are not included in A block. Okay, so A block is also done. Now we're gonna study the periodic properties of the elements. But before studying that, I'm gonna give you a table which is gonna simplify These all these periodic property and everything. So it will be easy to understand for you guys. So here is our property. It is how it will behave along a period. We will see that along a period and along a group. So, and here if the property increases, so we're going to mark it like this arrow, and if it decreases, we're going to mark it with this decreasing arrow. Okay, so let us see. First is our atomic radii. So atomic radii along a period it decreases, and along a group it increases. Now we'll ask why it increases, why it decreases. I'm going to explain that. First, see what happens, because in NEET they won't ask you why it increases or decreases. They'll ask you just, they will give you an element, two or three elements, and they will tell you to arrange them in decreasing or increasing order. So if you know this table, you can easily just do that. Okay, so next is our metallic property. So metallic property also decreases along a period, but increases along a group. That means if you grow in a periodic table from left side to right side, okay, so the atomic radii metallic property will decrease. But along a group, that means if you come up from low, so it will increase. So third is our oxidizing power. So oxidizing power, it will increase along a period and decrease along a group. So next is our valency. Now here valency increases along a period, but in a particular group they never change. Valency will be same for a particular group. Okay. Now we're gonna see ionization potential or ionization enthalpy. So we are writing it IE. That is along a period they increases, but along a group they decreases. Then our electron affinity. Okay, or electron gain enthalpy, that is also increases along a period but decreases along a group. Now electronegativity, that is also increases along a period but decreases along a group. Now comes our basic property. So basic property of oxide, it will also decrease along a period, increase along a group. Now we are not going to write about acidic property because the basic property decreases along a period. So naturally acidic property will increase along a period. So it will be kind of vice versa type. So we are not going to write that. So next is our covalent character and thermal stability. So along a period it increases, along a group it decreases. So these are the properties you have to remember with this table. Okay, so you can easily just arrange it quickly. So now let us study the properties elaborately. atomic radii. Now in atomic radii, suppose this is a atom and this is a atom. Okay. So it has a nucleus here and it has also a nucleus here. So there is a distance from this, right? So it is always will be half of this internuclear distance, always. By 2. Okay. Now there are 4 kinds of atomic radii. I want to discuss that. First is our covalent radii. So what is will be covalent radii? Its definition is simple. That is half of the distance between the nucleus of 2 atoms bonded by covalent bond. Okay. Then so it will be like this. Now many of you will not understand why it is overlapping like this. So it is part of the organic chemistry. Though I am telling you that in covalent bond, they share a particular number of electrons mutually. So they have to overlap like this. Okay. So if it is the nucleus, it is the nucleus. So it will be the internuclear distance and half of its value, let us assume it d. So d by 2 will be our covalent radii. Okay. So next comes our metallic radii. Now from the name you can conclude that there will be 2 metals like this. Okay. And their internuclear values half will be their metallic radii. So here you can see it is not overlapping. Okay. Because metals don't overlap, they share electrons like this. So next will be our van der Waals radii. Now van der Waals radii forms in cases of our noble gases. Okay, non-metals and noble gases. Most of the cases it forms in the noble gases. So you can see that it will be like this. Here its nucleus, here its nucleus. So distance is very much okay. So let us assume it is D. It is D double dash. So it will be. So its van der Waals area will be D by double dash. So here from these figures, you can easily conclude that van der Waals radii greater than metallic radii greater than our covalent radii. Okay. There is also a fourth radii, which is our ionic radii. So from the name, you can just guess that between 2 ionic elements, the internuclear distance will be there, ionic radii. So in ionic radii, now there are many things that we have to discuss. Ionic radii in case of anions. So in case of anions, the increase with the magnitude of the negative charge, the size of the anion also increases. Because what happens if there is a, it is, suppose this is the nucleus, so in the outer orbit there is excess of electron is added, so that's how anion is formed, an excess electron or one or two electrons is added, so that's how anion is formed. So if this is added, so let us assume that at first there are three or electrons on the outer orbit. So if there are three electrons at the outer orbit, so it has electrostatic force that is attracting those electrons, and there is a specific radii. So, but what happens if there is an extra electron comes? So now the electrostatic force comparable to initial time, now it gets weak. Okay, because it has to attract one more electron. So now what happens? This size of the anions get bigger than this parent atom. So size of anion is greater than the parent atom. Now what happens in case of cations? Now in cations, there happens this exact opposite case. Let us suppose there are three electrons like this. Now one electron goes out. That's how cation is formed, right? One electron is lost and positive charged atom or ion is formed. So if it goes out, okay, the outer orbit, this electrostatic force will increase, okay, because now it has to attract two electrons, so it will attract more. So what happens? Its size decreases. Okay, here it is anion, it is cation. So size of the cation will be less than the parent atom. But what happens if in a series they ask you anions, cations, and your neutral atom also, and they will tell you that to arrange it increasing order or decreasing order on the basis of their radii. How will you do that in less time? So there is a formula, that is Z by E ratio. If this Z by E ratio comes minimum for one atom, so its size that will be maximum. Okay, so let us see an example of that. Like N3 minus, O22 minus, F minus, Ne, that is neon, Na plus, Mg2 plus, and then Al3 plus. Now you can see that they are all isoelectronic. That means they have the same electron in their outer orbital, that is 10. It also has 10, it also has 10. Okay, because 7 plus 3 10, 8 plus 2 10, 9 plus 1 10, and we know that neon has 10. So it is also 10 because its atomic number is 11, so minus 1, so 10. It's 12, so minus 2, 10. It's 13, so minus 3, 10. So but their proton number will not change, right? So just write there Z by E value. What will be it? It will be 7 by 10. It will be 8 by 10. it will be 9 by 10. For fluorine, it will be 10 by 10, and for Na plus it will be 11 by 10, and for Mg it will be 12 by 10, and it will be 13 by 10. So whose value is minimum here? That is our N3 minus, because 0.7 will become, so it will have the maximum size among these particles. So let us write that. So after this, which has the second highest value, that is O2 minus, then that is F minus because it will be 0.9, then comes Ne because its value will be 1, then 1.1, that is Na plus, then 1.2, that is Mg2 plus, and 1.3, that is Al3 plus. So here you can see 1.3, that is Al3 plus, has the maximum value for Z by E. So it has the minimum size. So that's how we conclude in exam. So here our atomic radii is done. Now we are going to study ionization enthalpy. Ionization enthalpy. So what is ionization enthalpy? That is, let us suppose one electron is out from this Al metal or aluminum metal. So let us assume this has a ionization enthalpy that has a positive value, and there is another electron is emitted because its valence is 3, so we can emit 3 electrons. Okay, so it is I1, I2, then another electron is emitted, then it will be L plus 3, that is del H I3. It is also positive. So what is happening here? That is, let us suppose this is a Al metal. Now its outermost orbital, it has 3 electrons like this. So in case of the first electron, for it to go out, okay, it is this nucleus is constantly attracting these 3 electrons. So for the first electron to go out, it will experience lesser of opposite force, that is electrostatic force, because it is shared by 3 electrons, so we can easily make it out. But if we go after this is out, now what will happen? Uh, that is, the second and third will have more attraction now, because the third one is has gone now. So this nucleus will attract them more. So to, let us assume is any of them we want to make it out, then it will be higher value than IE1. And for the third, it, the nucleus never wanna lose it. Okay, so it will have the maximum value. So IE3 greater than IE2 greater than IE1 for a same atom or element. So what did we conclude from here? That to exclude a electron from its outer orbit, the amount of heat or energy we have to give, that is called ionization enthalpy. And for the same atom, it will come like this: I3 greater than I2 greater than I1. And the reason I have told you already. So now let us see the periodicity, how it happens. So we have already told you in the table that it is increases along a period and decreases along a group. Okay, period increases, group decreases. Now there are several exceptions on basis of this. That is, I of B is greater than I of B. So why it happens? So first let us write it on the basis of I of B is greater than I of B. Now why does it happen? So for no, uh, we have to know their electronic configuration. Okay, so what is the electronic configuration for this B? We'll write that. That is 1s2, 2s2, and for B it will be 1s2, 2s2, 2p1. Now we have to know a particular thing that is called shielding effect. So what is shielding effect? Suppose there is an electron in this nucleus. Okay, so it will attract it. That will be electrostatic force, but this electron will try to guard it from that. So it will be called our shielding effect. That is what you are supposed to know for this purpose. So what happens that this nucleus attracts this s electron more and more than the electron in this p orbital. Okay, it is because of this shielding effect. That's why I told you about the shielding effect. Okay, so if this electron is morely attracted, then what happens? That ionization enthalpy will be needed more. Okay, and you can see that in case of B, it has two fulfilled s orbital. So a atom don't wanna lose its fulfilled electrons because energy distribution between them is maximum. So they so that is gonna be stable, very stable, so they don't want to lose it. So we need to give more energy to it to release the electrons. So for that we have to give more energy. But in case of B, you can see that though it has two s electron s orbitals which are fulfilled, but it has one p orbital here that is filled with one electron. So it will go out, because if it's go out, then this boron will be fulfilled ion or element, right? That will be the same property as will be B. So it will easily go out. So we have to give less energy for it. So that's how IE of B is greater than boron. Okay. So same happens with in case of nitrogen and oxygen. Nitrogen has 7, it has 8 atomic numbers. So what will be its electronic configuration? 1s2, 2s2, 2p3, and it will be 1s2, 2s2, 2p4. Now with respect to p orbitals, as you can see that energy distribution here is more because this is half filled orbital. So if an electron we have to exclude from it, so will it cooperate with us or not? It will never cooperate because it is filled, half filled, so it is stable, so it will never want to lose its stability, so it won't cooperate with us to exclude an electron, so we have to give more energy to it. Okay, but here we can see if oxygen exclude an electron, it becomes half filled. So energy distribution is better than the previous. So if it gets half filled, the same situation happens when nitrogen is half filled. So it wants to exclude a electron. It will give you an electron happily. So here IE will be much less. So that's why IE of N is greater than O, though it is the previous period's element. Okay, so that's why it's electron gain enthalpy. Electron gain enthalpy. So in electron gain enthalpy, we have to first remove a confusion. Okay, so first let us see what is an electron gain enthalpy. That is the opposite case of ionization enthalpy. That is, suppose there are 3 electrons in the outer orbital. Now, from outside, we have to include an electron. For that, we have to give some energy. So that energy is called electron gain enthalpy. Okay, in simple terms. So its numerical value is can be same with ionization enthalpy, but its sign will be minus. Okay, so suppose it is some value x, but if we write it like this, it will be minus x. You have to remember it. Sometimes they ask in questions if this is ionization enthalpy, so what will be the electron enthalpy? Just you have to remove the sign, that will be it. That along a period, the electron gain enthalpy increases, and along a group this decreases. So this is the periodicity of these things, but first is our electron gain enthalpy of Cl is maximum than fluorine. Now why it happens? So fluorine has atomic number 9, so I want to write its electronic configuration: 1s2, 2s2, 2p5, and for this chlorine it will be 1s2, 2s2, 2p6, 3s2, 3p5. That will be 17. Okay, now we can see that if one electron is added here, so it will be fulfilled. So its value will be much less. But we always said that electron gain enthalpy is deducted in minus V value. So if value decreases in positive case, it increases in negative case. So for halogens, where the lesser energy will be needed, so its electron gain enthalpy will increase. because of its minus is written behind before it. So that's why halogens have the highest electron gain enthalpy. Okay. Now, why, but why does it happen? Because it also has here this thing, because this 2p is shorter in size. So that's why electrons are here, 5 electrons are here. So if we want to include an electron here from outside, so what will happen? This electronic, that is electronic force will hinder it to entering from that. But in case of chlorine, it has much bigger, because it has 3p, so it will be bigger than 2p orbital. So inter-electronic force is much lesser here. Okay, electrons are spread out like this. So any electron can come inside easily than this short sized 2p orbital. So here electron gain enthalpy of chlorine is greater than fluorine. Now, as you can see, there's, in case of sulfur and oxygen, same thing happens. That sulfur has 3p orbital and it has also 2p orbital. Okay. So if electron wants to enter, the same thing happens, that inter-electronic force of this thing does not help to enter the electron in the orbital. So it hinders it. So that's why electron gain enthalpy of sulfur is greater than oxygen. Okay. Now we're gonna see that why group 2 metals have lower electron gain enthalpy than group 1 elements. That is, group 2a metals have lower electron gain enthalpy than group 1a elements. Okay, because you will see for group 2a elements, this electronic configuration is ns2, and for group a 1a it will be ns1. So it is already fulfilled, but here it is not fulfilled. So if we want to include an electron, so it will want from outside source that give me an electron, so I can be fulfilled and I will be the stable atom or ion. Okay, so it will want it. So we have to give much less electron gain enthalpy here in numerical value. I am coming why it is greater, but in case of heat, we have to keep much bigger value, right? Electron gain enthalpy, we have to give it much more because we are including it electron, so we have to add an p orbital here and it will go here. So there is many complicated things happening here. So electron gain enthalpy will be much more, and in many cases there are also positive electron gain enthalpies, um, like beryllium, magnesium. Okay, there are positive electron gain enthalpies, but if we are gonna see not its numerical value but with minus sign before it, so what will be it? It has the lesser minus value that is close to zero, but it has much more bigger minus value that is distant from zero. So what will be it? The electron gain enthalpy will be here much bigger of group 1a than group 2a. Okay, because minus sign is sitting before it. So that's how it happens. Now we'll come to electronegativity. In electronegativity, we're gonna see that along a period it increases, along a group it decreases. Now what is electronegativity? That is Electronegativity is the tendency of an atom to attract the shared pair of electrons towards its nucleus when the atom is covalently bonded to a molecule. Okay, so like this, they will which atom attracts more, that will be more electronegative. So in electronegativity, there are no exceptions. Just one exception is there, that is electronegativity of carbon is equal to, or the electronegativity of sulfur. Now it has no explanation because it is derived from practical experiments, so it has no explanation like that. Okay, so it is like this. Now there is a formula for electronegativity on Mulliken scale. There are many scales for electronegativity, but on Mulliken scale, it is electron gain enthalpy plus ionization energy with the signs included, okay, by 2. So if they give you two values of electron gain enthalpy and ionization enthalpy and ask you which is more electronegativity, so you can just add it and divide it by 2. So you will easily conclude from it. Okay. Now there comes a thing that is called diagonal relationship. Let's write it, diagonal relationship. Now, what is diagonal relationship? A diagonal relationship, you will see that the adjacent groups metal will act like its previous group's metal. Okay, so for that we will call it staircase phenomena. So we are gonna see that. First write it down. Okay, so what happens that practically is seen from practical experiment, that like this, if you write the shortest periodic table I have told you, and you write this, so you will see that if in this kind of diagonal relationship, you will see there that diagonally, that metal which is adjacent to the next group, that behaves like this metal, that is means Li will behave like Mgb, Al will behave like beryllium, and silicon will behave like boron, like this. Okay, so here is our periodic table is ended.